Hello, everyone, and Happy New Year. Welcome to another session of Dr. Spotfire. I will be your host for today's session, Dr. Spotfire. I'm your host, Jose Levi Aguirre, and I'm part here of the TIPCO, and today I have the honor of hosting Suera Cota that will be continuing to talk about machine learning introduction, moving from supervised regression into supervised classification. These methods are used to place any data observation into a predefined category or bucket. Since not all the data points have labels or are well labeled, um, that's where we're going to cover. We're going to also try to touch up on how to group unstructured data if we have time, which falls into the unsupervised methods of machine learning. Remember that we have two, the supervised and unsupervised methods. And we will build, evaluate, and predict using these models through Spotfire low-code data functions interface. So welcome, everyone. Welcome, Suera, and thanks for joining.
Yep, thanks, Jose.
Okay, let me just pull my deck. 1 second here. Okay, and share my screen. Okay, let me go to full screen mode. Okay, so here are the QRC codes. If you want to scan them, we will be happy to add you to the LinkedIn network to updates and networking. We'll leave this for a few more seconds if you need to take screenshots or just take the QRC codes or not, if not, we can send the links later to the stream. So yeah, classifying group data with machine learning. And the next session is going to be on February 1st, and we're going to be learning about the OC Pi connector for Spotfire. This is going to be super exciting because I remember working with OC Pi. It's kind of a hassle. You need a certain components in order to connect, but now with the new Spotfire that is constantly evolving and enhancing, improving continuously. Connecting to OC Pi is a breeze. All right. So remember to subscribe for recorded session on YouTube. We're streaming live, LinkedIn, YouTube, and what's the other one? I just got blank.
Facebook.
Oh,
So we're
Facebook.
on
All right.
Facebook, LinkedIn,
Yeah.
and YouTube.
Thank you, Sweta. Okay. Well, that's it for now. Let me go back to, if you can remove me from the. Okay. There we go. How remove me? Oh, okay. Thanks, Sweta.
Yeah, so awesome. I can go ahead and then kind of start. So Jose just kicked off for us. And today, let's see if we can bring up this real quick. So today we're going to do a continuation from our last session, which was December of last year. We talked about regression, and today we're going to start talking about classification. So this is just our standard slides. Um, so last session we talked about regression. This is just a little bit of a recap. So under the branch of machine learning, there's kind of two different types of divisions. We have supervised learning and unsupervised learning. So we are focusing, last session we focused on supervised learning, which is where we're dealing with labeled data. That essentially means that if you have a data set, every single data point observation has some type of label associated with it. And these labels can be either numeric or categorical, depending on the data type. And that's where supervised learning breaks down into regressions versus classifications. So last session, we covered regression, which means we're trying to predict a numerical target or outcome from one or more features. So you might, for example, be interested in predicting stock prices. You might be interested in predicting like median housing value, or anything that has to do with numeric data.
Like, for
And
example, determine the amount of widgets a company has to produce or estimate the number of sales that will happen in the future?
Yes, exactly. So any type of numerical outcome.
Okay.
Yeah, and this session we're interested in classification. So this is, on the other side of regression, where we have some type of what we call a categorical target or categorical outcome. So if you're not too familiar with these terms, numeric and categorical, we did a session on exploratory data analysis a couple of months ago in October. So feel free to check those out. But a categorical outcome essentially means that your data belongs in some type of like predefined classes or labels. So for example, you might be interested in looking at a picture and saying, is this a dog or a cat? You also might be interested in looking at like personal information. Like say you have demographic information about some type of candidate and you want to ask, is this candidate going to be successful in this new role or not successful? So it's whenever this new data observation belongs into some type of classes, as we call them. So again, classification is just predicting a categorical target, and this is from one or more features that are in your data. And
Like,
there's, yeah.
oh, wait, I was going to also make another example for classifications. Like, for example, predict whether or not a customer will default in the credit card bills, right? Or trying to predict what's on a given image, right?
Yes.
Those are kind of okay.
Yeah. And there's a further breakdown of classification. We can say that there's both binary classification as well as multi-class classification. So this is just concerned with how many classes or labels you're trying to predict. So in a binary classification problem, you have like a binary outcome. So you might be trying to predict a yes/no answer or a good/bad prediction, dog or cat. So again, there's only two defined classes, and multi-class just refers to two or more classes. And last time in our session, we actually covered, we focused a lot on linear regression because linear regression is kind of one of the fundamentals for regression. It's an extremely commonly used statistical technique because it works very well in practice. And today we're going to cover its kind of sister counterpart, which is logistic regression. So logistic regression, contrary to the name, is actually used for classification. The reason it's called logistic regression is because it's very closely mathematically related to linear regression, hence the name regression. But again, it is used for classification. So you are predicting some type of binary outcome in this case. And here I've actually kind of inputted in, well, let me see if I can exit out of this for a second. So last time in our slide deck, actually, we had this. We had this formula right over here, and this is the formula for linear regression. And it's closely related to logistic regression because what we're doing instead of predicting some y numeric value, we're predicting some type of log odds for our classes. So we're trying to predict the probability that any type of data instance belongs to one class or the other class. So let's say that you have, again, we're working with a dog or cat example. What this model is going to predict is the probability that this image is going to be a dog. So it's going to give a probability score from 0 to 1, if that makes sense. So that's the general gist of a lot of these statistical and machine learning formulas, is that they're interested in predicting some type of probability score. Because again, computers work with numbers, and when we're working with like these distinct like outcomes, when it comes to like dog, cat, etc., you need to translate them into some type of numerical value so that these algorithms can learn from them.
So on the output, you have a value from 0 to 1, and 1 means that is very likely for that to happen, if not 100%. And the lower scale, maybe 0 or 0.9, is very unlikely to happen, right?
Yeah. So like at a high level, let's say that you're interested. The question that you want to ask is this image a cat? And let's say that you predict something that is your prediction is going to give you a probability score of 1. That means you're fairly confident that this is a cat, and that's what your algorithm is telling you. But if you output a probability score of 0, that means this is probably not going to be a cat. It's probably going to be a dog. And if you output something in the middle, that means your algorithm's just not sure actually what this image is. And so this is like a high level overview of what logistic regression is. And now we're going to be looking at how we can do logistic regression in Spotfire. So Spotfire does actually have an inbuilt tool for logistic regression, and we also have data functions available for it. But just to give a general setup, the data set that we're going to be working with here is a credit risk data set. So let me see if I can bring this up real quickly. So we have each row in this data set is going to represent a different type of person. And you have this response column, what we're trying to predict, called a person's credit standing, whether it's good or bad. And then the rest of the features in this data set are related to, their credit account, their account, as well as their own personal demographics. So looking at this, as we do with any type of data set, we start off with some EDA. So here we have a distribution of the good and the bad labels in our data set. So it seems that we have a pretty balanced distribution. This is actually pretty important for later. We have an imbalance if we have many more of one category than the other, but here our data tends to be pretty balanced out. And over here on the bottom, I also have ways that we can visualize our response variable with other variables in our data set. So if we're interested in looking at credit standing with other variables, so here, for example, if we're looking at credit standing and its relationship with checking account, we can make that into a bar chart colored by different categories. Or if we're interested in looking at credit standing with a numeric variable like residence time, we can have this in a box plot over here. So this is, again, ways that we, standard ways that we do to check how our variables associate with one another. And over here in the top right, we covered correlation matrices before, but it's important to have no multicollinearity in logistic regression, and this is something we'll come back to. But again, this is all part of our EDA at this point. So,
okay, and you're going to explain what multicollinearity is, right?
Yeah. I'll probably jump back to that. But why don't we actually set up talking about how this modeling process actually goes? So
Okay.
if we go to tools, we have this item here called classification modeling. So if you click on classification modeling, you have the option to name your model, and you can select the modeling method. So here I've selected logistic regression. Another option is also a classification tree. And I've selected the data set of interest that I want to work with, which is our credit risk data set. And here, our response column, what we're trying to predict is credit standing. And when we choose a response level, that again goes back to the main class that we're interested in trying to predict. So let's say that I'm interested in trying to predict good credit standing. And the reason for this is because I want to target customers who have good credit standing for a 2022 promotion. Say that I want to offer them like loan discounts or such. So this is the main class that I'm interested in. And now we can actually build up the actual formula. So based on my EDA, I want to choose all the features as input to this model. So here I've selected all the relevant features, and then I'm just going to add them here. And then we can just click OK in order to get a model, get a DXP page like this pop up. So that's how this logistic regression model was built. And what I've actually done on this page is emphasize some of the charts that I think are like most useful. So here we have a table of coefficients charts. So this is actually going back to our logistic regression formula and telling us, what is this formula going to be derived to be. So if I go back to my slides for a second, you can see that here we're talking about logistic regression, assumptions and interpretation. So that coefficient table is essentially telling me if we have any type of coefficient value, it's telling me how I can actually interpret that model. So for example, for logistic regression, which is again pretty similar to linear regression as last time, the general formula is that for every increase in one of our explanatory variables, the outcome increases or decreases by an exponential amount on average. So if this is our logistic regression formula, so we're predicting credit risk from just one variable, and we have this value of 0.13, and this 0.13 comes from our table of coefficients, the estimates. So let's say, for example, we have 0.13 right here. The way that we would interpret it in context of that formula is just to say for every year increase in age account, the odds of good credit increases by 1.14. So this is a multiplicative factor.
Oh, interesting.
Yeah.
So going back to the Spotfire, what are the outputs that Spotfire generated?
Yeah. So the way perhaps I should have showed this, but if we create something, for example, called my model, and again, I just go back to input all of these directly in, and let's say that response level is good. So if you just give it a second to load, this is exactly where you're going to see pop up. So
So
this is
that's
very similar to the page I showed before. We have our
mhm.
model summary, the table of coefficients, and the available diagnostics. Um, one thing that I did is I removed this chart for the residuals versus fitted, and I brought in this ROC curve because I like using ROC curves, and this is something that we're going to actually cover. I think like right after actually on how we can. This helps me better evaluate models.
Yeah, that's pretty cool that Spotfire has everything out of the box. So you just
Yeah.
put the inputs and you have all these outputs, and then you can polish a little bit to have a better presentation or look and feel.
Yeah, exactly. So this is the exact same model as what we were just looking at. And I think I've added in the ROC curve plus this other text box area, which we'll go into. Um,
Okay.
because this also, yeah, this so far we've covered how we built our model as well as how we can interpret it. And on this slide, I've also added some things about assumptions because just like linear regression and a lot of classic statistical methods, there are always assumptions that we have to adhere to. um, so the assumptions, for example, for logistic regression are that you have some type of categorical response. You have independent observations, so that it just means that each one of your data points is independent. If we're working with different people, we know those are independent observations. And we also have no multicollinearity. So this is something that I briefly mentioned and Jose asked about. Um, so if you go back to here, we're looking at our different numerical variables and we're looking at all the correlation between them by creating this correlation matrix. And this is created through the data relationships tool. And I've just highlighted the higher ends of the spectrum. So you have a high correlation between variables if the correlation coefficient is going to be 1 or -1. So I colored those to be red, and anything near 0 is going to be blue. So luckily here you can see that there's not a high correlation between these numeric variables.
So this is showing basically a gradient, right, between those colors,
Yes, exactly. So if we go over here and we look at um,
the colors.
so the colors, yeah. So you can see that anything in the danger zone for multicollinearity is going to be near 1 or -1, and anything that's more neutral is going to be near 0 strictly. So
Okay.
we can see that we're pretty good here because there's not a um, there's no high correlations between variables.
Yeah, and the white, because I see white spaces, there's nothing to compare between H and H, right? That's why
Yeah,
it's
so
white.
because it's the same variable, so it's going to be 100% correlated. That just automatically is not in consideration. It's just
Okay.
different types of variables that we consider.
All right. And guys, if you have any questions, please feel free to ask them through the channels, and we will be able to see it and answer the questions.
Yeah. And a couple of the other assumptions are just that we have no outliers and we check for that our variables are linearly related. So we also covered this in our linear regression session. So again, a lot of these are quite similar in terms of the interpretation, at least. Logistic regression does deviate away from the assumptions as well as in the mathematical formula a bit. But at a high level, the idea is the same.
So in other words, the data has to be somewhat clean, and there are tools and methods to clean outliers, anomaly detections, just to have that, and then be able to apply these methods to a better output, right?
Yeah. Mhm.
Excellent.
Exactly. So if we go back to that logistic regression page that I just showed, so far we went through how you can look at this table of coefficients to make sense of it. And based on this table of coefficients, we actually get this variable importance chart. It just shows us what are the top features that best contribute to predicting credit standing. And now on this bottom leftover, we have this ROC curve. So this is something that we're just going to go back to talk about a little bit. So if I look over here, before we talk about the ROC curve is used for evaluating a binary classification model. So again, we're working with a binary classification technique because we're trying to predict good or bad credit standing. Um, and when it comes to evaluating binary classification models, we do need to go back a bit to talk about some of the basics. So one of the most simplest visualizations that we use is called a confusion matrix. And what a confusion matrix does is that it's literally this 2 by 2 matrix, and it it counts your predicted values against your actual values. So for example, if we're trying to predict that something is a 1 or a 0, and that something, and we predict that something is a 1, but in reality, in reality, it also is a 1. That means we have what we call a true positive. So this is just common nomenclature for describing these terms. If we predict that something is a 1, but it's actually a 0, that means we have a false positive. And likewise, we also have false negatives and true negatives. So these are how these terms fit into this confusion matrix. And based on these true positives and false positives, a common statistical tool that we use is called an ROC plot, specifically a receiver characteristic operator plot. So what this does is it takes the true positive rate on the y-axis and plots it against the false positive rate on the x-axis. And here I've just put in the formulas for these. We won't go too much into depth on what these are, but again, if you have a general understanding, it's looking at those the two different types of rates that we saw before based on that confusion matrix. And what we're trying to do is find a trade-off between the true positive rate and the false positive rate. So this is helping us identify what a good model looks like. This blue line over here is just a baseline random model. And what that means is you can have something that randomly predicts 0 or 1. You're going to predict anything with like a 50-50% chance. And if we make a model, we obviously want it to perform better than that. And the way that we measure that is by plotting our model's true positive rate against our false positive rate. And it should be above this blue line. And more noticeably, it should be close to this upper left corner so that it goes along this general curve as you see here.
Mm. Okay, yes. Neil had a question about if you could explain a little bit more about the ROC curve, but I think you cover, unless you think you need to go a little bit deeper for Neil to understand. Thanks, Neil, for the question, and thanks for joining.
Yeah, I think we're going to go a little bit in depth so you can see how this looks like in Spotfire. But hopefully this gives a good understanding of what we're looking at least in terms of these plots. So what we're trying to evaluate for. I also made a side note here that for those who are interested, there's other types of curves too that we use for binary classification evaluation. So precision recall curves, as well as other terms such as sensitivity and specificity that we try to measure. And this, again, all falls under this umbrella of model evaluation. So if we go back into Spotfire, what we saw was this general ROC curve from this logistic regression model. And what I did is I went in and added in the custom curve for y of x equals x. So this, again, is just showing our baseline or random model. And this is showing our logistic regression model. So it looks like, so it's performing better than a random model because, again, it is following above this black curve, and it's also coming closer to this upper left corner. And oh, perhaps I skipped over this before, but another quick measure that we use to actually quantify this, like how over the curve is this term called area under the curve. So this is just explicitly measuring the area under this orange curve of our model, and a higher AUC score close to 1 it tends to represent a better model. So here we have an AUC score of 0.82.
Which is
are there any questions? Yeah, which is good.
Yeah, which is good. Mm-hmm.
Mm-hmm.
I don't see any questions, but feel free to post any questions that you might have, and we'll try to answer as we go.
Yeah.
I have a question about I don't know if it's time to cover multicollinearity that you mentioned earlier.
Oh yeah, we can go over that. So I mentioned that one of the assumptions for logistic regression is no multicollinearity. And this is something that we checked in this heat map over here, or this correlation matrix.
So that means that you have multiple correlation that can adversely affect the regression estimates?
Yes.
Or you have multiple independent variables with multiple regressions?
So you have multiple variables that are highly correlated, and this isn't good for regression. It tends to sway the results or mess with the model interpretation as well as mathematical calculation.
Okay, I see. Thanks.
Hmm. Yeah. So
Um,
again, the way that we check for it is through this data relationships tool, and then making a heat map. So we did actually cover this in our last two sessions.
we have a comment from Filippo Granchi. He's saying that it's very interesting to recap on logistic regression and relative metrics. He didn't fully know about these Spotfire features, and he's glad to know. Thanks, Filippo.
Yeah. Linear and logistic regression are probably the most commonly used techniques for regression and classification. Um, they're the simplest methods, but they work very well in nature. So it's nice to be able to see everything from data preparation to evaluation that you can do in Spotfire. And so the bulk of what we covered so far is just on logistic regression. And we can move on to the other available tools that we have for classification.
So, are we moving? If you go to the very first slide when you have the tree of how is yeah, right here. So we are just like an overview map of what we're looking at. Machine learning, you have supervised learning, which is labeled data, and unsupervised learning, which is unlabeled data. We already covered in the last session the regressions, numeric targets, which are more basically numeric, predicting stocks and things like that. And then you have classification, where you trying to predict the yes, no, for the very basic binary outputs of a categorical nature, or maybe more complex of if it's a dog, a pear, something in between, or what type of shape is using. Like Google uses a lot on their AI um, algorithms. So now we're moving into unsupervised learning. We're going to touch a little bit of that.
So we're still in supervised learning. We're going to cover a few more methods for classifications. So far, we just covered logistic regression, but we actually have a variety of other tools that you can also use. So more
Okay.
than just one model.
Okay, perfect.
Yeah, so
Thanks, Pedro.
here I'm going to cover, in the last several sessions, we've been introducing our Python or our data functions community page. So this is where we've been readily putting up Python and R data functions that you can use right in Spotfire itself. Um, so anyone can actually go ahead and build their own Python and R custom data functions. And then we happen to release several on our community page, which is linked down here. And today I'm going to talk about some of the algorithms that we have for classification again. So we do actually have a logistic regression Python data function. And a couple of the other ones that we're going to cover are SVM, which stands for support vector machine, random forest, as well as the neural network. So these are actually algorithms we used in our last session for regression, but they can also be used for classification.
So one
So
question,
I'm
Sweta.
going to,
These algorithms, are they out of the box of a Spotfire, or you have to download from the community and integrate it in your Python and maybe do some tweaks, or you can incorporate yours?
yeah, so you can do either or. So if we go to, so I have here, if you go to tibco.com//fx, you'll be redirected to our data function library. So you can see the variety of data functions that we have available. And here is just like the ones from modeling and prediction. And if you click on any one of these, I think I actually clicked on logistic regression before. You can go to get data function and download the data function and directly import it into Spotfire. From there on, you can see the code and edit it if you wish, but there's a way to do this with like a no code option at all. You can just drag and drop these data functions and run them based on the inputs and outputs, which we're going to
Okay.
show in a little bit.
Okay. So you're going to go through an example of downloading the actual thing, maybe dragging and dropping into Spotfire and have it available to use.
Yeah, I can show that. Um, so so like for example, if we have this logistic regression data function, I might actually already have it in my downloads. So here, we have logistic regression, and the way that it's brought in to Spotfire is just going to data function properties, and you can go to register new, and then import, and then as long as you've downloaded that
Oh, but you have
release
to,
component.
it, it downloaded a zip file. You have to unpack the zip file, or it's going to read it like that? the zip
So
file.
it downloads a zip file. You just need to make sure you extract it. If you're, on a Mac, you can do that automatically, or if you're on Windows, you just have to extract all. And then
Okay.
once you open up that, you can just go ahead and bring it right in.
Okay.
Yeah. So one thing that we've done is we've saved a lot of these data functions to our Spotfire library. So the way that I actually access these data functions is just going to the FX tab to bring out this FX flyout. And I go to find items in library, and I can see all the data functions that are available to me. So the way that this was actually brought there is just that if you go to any data function and you click on edit script, or sorry, um, if you click on register new, you have this option to save it, and you can save your data function to the library.
Okay. And
So you
everyone
can
can
do
use
those
it.
with the ones, yeah, so you can do
Yeah.
those with the ones that we have available on the
And
community.
this is something that was recently added to Spotfire. These data functions, I think, is great. And you can also pin, if you have a lot of data functions from a large corporation, you can pin the ones that you like and have them handy.
Yeah, exactly. Yeah, so you can pin the ones that you have to the flyout. So I'll be walking actually through a lot of these that I have pinned right here for today. Um, yeah, so going back to the models that we're going to discuss today, the algorithms that we're going to discuss today, we have our support vector machine, random forest, and neural network. So these are pretty complex machine learning algorithms, but in case you needed like a one-liner on what exactly these models do, I just thought I would include a quick description right here. So the support vector machine, the best way to actually understand these at a high level is just to visualize them. So let's say that you have two different types of classes. You have these blue circles and you have these red circles over here. So let's say that this represents everything that's good in blue and everything that's bad in red. So it's representing our two classes from our data set. What the support vector machine tries to do is tries to find what we call a linear classifier. So this is what this line represents. Again, we're looking at this in 2D, but let's try to find some type of line that best separates these two classes. So the support vector machine is trying to maximize the distance between these two classes based on that decision boundary or that line, while it's also trying to minimize any penalty for items that are wrongly classified.
Okay. There's a question before we move on to the next one from Filippo. He's saying, just to understand, we have to perform data preparation manually beforehand. So he means like data wrangling, missing values, categorical variables, encoding, mapping, etc., or everything is done by Spotfire. And so let me answer part of this question. You can do it in a Spotfire before applying these models, before applying these functions, these algorithms, because one of the assumptions that we saw earlier is that the data has to be kind of clean with no outliers, with no with all those assumptions that we saw earlier. Do you want to add more on that, Sweta?
Actually, yeah. So a lot of our data functions actually handle the data preparation. So like encoding categorical variables, for example, those are handled by these ML data functions. We also have data functions in specific categories, like for preparation. So for example, a one hot encoder is how you might encode categorical variables. So you can take like a good, bad response and make it into 0 and 1s. So a lot of these algorithms actually automatically do that for you, but we also have it as a separate data function too, if you wish to go that route.
All right,
And
thanks.
the data functions do tend to account for null values. Usually they tend to drop null values just because it's hard to otherwise, infer what the user would want to do. But this is something that you can alter in the data function itself, or you could try to prep that data in Spotfire before you pass it on to the data functions. Yeah. And just for the sake of time, I can quickly gloss over these other two algorithms. But our random forest essentially is an ensemble of classification trees. And so in Spotfire before, we had a classification tree tool. And a random forest works by creating an ensemble of these different classification trees and tries to see what is the majority result. So what are all these models trying to agree on? Unless we have a neural network. Neural networks are, very common nowadays to use, but they use these things called neurons to take your input data and translate it into more complex patterns and then output something, which tends to be a prediction. So while that was a very quick explanation of the models, the main part that we wanted to focus on was how you can actually use these data functions. So here in my FX flyout, I've pinned the data functions that we just talked about, the TensorFlow classification, the SVM, as well as the random forest. And what I've gone ahead and done is actually run these models on our data set. So I have Spotfire 11.6, and you can look at you know, the data function results in our data canvas. So for example, if I click on the random forest, I can see exactly what the inputs and outputs were to this function. So if I go over here and I click on this button to edit the FX flyout, I see that the FX flyout is actually popping up for that data function, and you can see exactly how I've configured this. Well, actually, one thing I should quickly mention is that since someone asked about data preparation, the exact process that I did was I went ahead and used one of our data preparation tools. So I used the one-hot encoder first to encode our credit risk data. So a lot of this data is actually categorical variables, and I just preferred to directly encode it myself as opposed to letting the other algorithms handle this, because I just wanted to have that here as a data table. So I use this one hot encoder in order to encode several of these several of these features, and then I passed it on to our SVM, random forest, and TensorFlow. Does that make sense so far, Jose? I was just wondering if you had anything to add on this data function workflow.
No, yeah, it's perfect. If you guys on the audience have any questions, also feel free to post them.
Yeah. So the way that like one of these are set up, for example, is that if I go to any of the data functions that I have pinned, I just need to specify my inputs and outputs. So here I'm going to specify our credit risk data, which now I have one hot encoded based on that other data function. And then I'm going to specify what exactly is the target column that I want to predict, credit standing, and then just say what is a problem type. So in this case, it's going to be classification. Because again, this is a model that can be used for regression and classification. And with that, you just click the OK button, and you should see exactly what is going to. You should see exactly the outputs that are going to pop up from that model, and you can import them, or you can import some type of subset of them, and that's what I've done here. So you can see which ones I've explicitly chose to output. So that's just looking at one of the models. And once we've actually run these different types of models, what I've gone ahead and done is, so far in our predictive modeling pipeline, we have encoded our data, then we have trained a variety of different types of models. So far we have 3 different models that we've worked with. And then after that, what we want to do is use these models to predict our new data. So the way I did that is through this data function I wrote called just score new data using a pickled model. So in our last session, we briefly covered how you can save models as pickles as pickle files. So in Python, we have a pickle library in which you can save models as binary values in Spotfire. So this is something that you can uncomment in the code, and that's exactly what I did, just to dump this to a Spotfire document property. And then I just reuse this scoring data function in order to score new data using those models. So here the last model I ran was the support vector machine. I specified that that's my model of interest. I specified what my new data is, and then I output both predictions as well as probabilities. So this is a data function that I've reused on every single model that I've run so far.
Okay.
And yeah, and it's a little bit hard to put into context, but now that we're able to score new data, what we can do is go, so now that we've been able to predict on new data, what I tend to do is bring those predictions back into our original data set. So I have our demo data credit risk, and I also have our demo data credit risk, where I've now taken the predictions of our models and I've just added them as calculated columns to our data set. And what this does is it has our original data plus the model predictions all in one data table. And what
Oh,
that
okay.
allows me to easily do, yeah, so what that allows me to easily do is, so now, yeah, you can envision that you have a calculated column for, or you have a column added for each one of your model predictions. So for example, we have logistic regression predictions, we have random forest predictions, and we have SVM predictions. And we also have over here credit standing, which is the actual true value. So using this data set now, I've gone ahead and made a confusion matrix. So here, this is a confusion matrix for logistic regression. And this
Yeah.
is looking again at,
The false
you know,
positives, the false
yes,
negatives.
yeah. So good is good. Since good is what we're trying to predict, that is our true positive. And this is also our true negatives. And likewise, this is how we visualize a confusion matrix in Spotfire. So this is actually created using a cross table, our
And we can
cross
see
table
the
visualization.
we can see the overall score at the bottom left of that, how accurate this is from
Yeah.
different
So
angles. Yeah.
so on the left over here, I've added in the accuracies of these models as KPIs. So accuracy is computed as how many your model predicted right that were actually right out of all the model predictions. And to do this, I believe I just did a simple expression for each one of these. So yeah, I just checked to see if the actual credit standing matched what our prediction was. And if it was, I said, let's give that a 1, else let's give it a 0. And this is just going to give you an accuracy measure. So this is repeated for all of these models over here.
Oh, that's pretty cool. What about the numbers on the bottom left?
Yeah, so that has to do with the AUC ROC. One thing I'll mention before we go into that is here we have, again, this confusion matrix, and you can also look at different types of models. So we have logistic regression predictions, random forest
Mm,
predictions, SVM. The random forest has the most, you know, the most number of correct true positives as well as true negatives. So that is something to note, that it looks like it also tends to have the higher accuracy. But of course, accuracy doesn't always tell us everything. So that's why we look at these ROC curves. So here, the ROC curve was generated here through a data function. Just like I had a data function for using these models to score new data, I also had one for creating the ROC curves. And this is something, again, that's available on the community. What it does is it takes the probabilities that were outputted from that scoring function, and it takes the true credit standing values. So it takes our probabilities and our target, and then it just calculates. Oh, it just goes ahead and calculates the ROC, and we can use that to construct the graphs. So what I'm trying to say at a high level is that these processes like scoring as well as model evaluation with ROC can be done through a data function that I've reused on every single one of our models. So I've ran this for all of the predictive models that we have. And here I'm just showing two for random forest and logistic regression, but we can see that this is the ROC this is the ROC curve for logistic regression, and this is the ROC curve for random forest. And the random forest tends to fall much higher than the logistic regression, and it also has the higher AUC score, which, as we discussed before, is indicative of a better predictive model.
so it's a better predictive value, but remember that correlation doesn't imply causation. So you have to also use your judgment to see which one is best for what you're looking for. And it doesn't mean that one method is better than the other. It's just in some cases one method will fits better on a specific case or a specific method.
Yeah, exactly. So that's why it's good to have all these model evaluation tools together, so that you can, make the best informed decision based on what you're looking for,
So
whether it's like a balance of.
how
Mhm.
long did it take you to come up with all these? Well, you already have the data function, so all you have to do is
Yeah.
put the values, right? Input the values, and then you can compare between different methods.
Yeah. So, this whole predictive modeling stage, what I first did is just, again, prepare my data, which is just a run of a data function. Then I chose a subset of modeling functions to run. And again, this is just, input output. You don't have to even touch the code at all. You just have to specify what your inputs, what you want to input to the model, and it already spits out everything for you. And the whole scoring and model evaluation process was also a reuse of existing data functions. So it's an entirely low code or no code process, given that all these are publicly available.
Yeah, we have a comment from Filippo. Thank you, Filippo, again. He says it's impressive and really many things to play on for a data scientist. So it's a great
Yeah.
tool for data scientists.
Yeah, exactly. Yeah, so are there any other questions on, I guess, all these classification techniques that we've covered?
Not from what I can see. I think we
Okay.
covered all the questions. And if there are
Yeah,
any
so
questions later on after this video, just put them on the channels, Facebook, LinkedIn, or YouTube, and we'll be able to answer.
yeah. So I did have a quick slide just to mention that you can do more than just binary classification using these data functions. You can also do like multi-class classification, although that isn't something that we're going to show today, but the same ideas translate over. And real quickly, I think we'll have another session that covers more on unsupervised learning. But
Okay.
yeah, so
So that's the
unsupervised
slide
learning
that I
has,
was that
yeah,
is the slide that I was talking about at the beginning. That we, in order to cover most of the machine learning, then probably another session will be solely for unsupervised learning. That you're
yeah,
gonna just touch the surface of it. So we'd like to serve as an introduction for the next session.
yeah. So really, we've covered, all these nodes over here. We talked about regression in our last session. Today focused on classification, both under supervised learning. And now we'll just briefly introduce unsupervised learning. So here, I just mentioned what is unsupervised learning used for. It's unsupervised learning is when our data is unlabeled primarily. That's when we resort to unsupervised learning techniques. And it's used for a wide variety of cases, everything from EDA to anomaly detection, which we've also talked about in the past, and as well as again, feature selection and segmentation of your data. So one thing that I'll show real quickly is that, let's go to this page over here. So we have a classification data set, and we have a supervised data set in the sense that we know what the labels are for our credit risk data. So one thing that I thought that was interesting is that why don't we test a few types of unsupervised models and see where they agree and disagree based on our labeled data. So here I've run the local outlier factor as well as the autoencoder. So these are two unsupervised learning techniques. They're actually commonly used for anomaly detection. And what both of them are going to tell us is they're going to try to predict what are the outliers in your data or what are abnormal data points. So let's say that our autoencoder as well as local outlier factor make a prediction for each type of data point. So here, this is the local outlier factor prediction. One implies that a data point is normal, and negative one implies that a data point is abnormal. And I've done the same thing as before, where I've added in that column to our data set that contains all our predictions. So those should be added in over here. Yeah, you have your LOF prediction as well as your autoencoder prediction. And then I just wanted to see how these two models are predicting what's normal versus what's abnormal. So if we look at this pie chart, we're looking at all our demo data. We're looking at our credit risk data again. And we're looking at where our models agree that something is abnormal. So here we can see that they agree on 7% of our data as both these models agree that 7% of our data is abnormal. There's a good chunk of it that they both agree is normal. And there's somewhere they disagree on whether we have normal data or some type of outlier data. So here, for example, it looks like the autoencoder more often predicts that something's abnormal, while the local outlier factor predicts that it's normal. So this is just an example of something that you can do with unsupervised learning on top of supervised learning, if that makes sense. So
Okay,
here,
yeah.
and at the bottom, you can just look through all what's classified as to be normal. And you can also color this by your variable of interest credit standing, since we have a labeled data set here. And there's many other ways that you can explore your data using these types of models.
Okay, we have one question from Filippo again. It says,
Yeah.
Is there the possibility to use out of the box the famous gradient boosting algorithms in Spotfire or XGBoost?
Yes, so we do have a gradient boosting. We do have a XG boost data function. I think we have one written in R, and we're releasing one written in Python to our community exchange. So if I go back here for a second, oh yeah, so you can actually see it right here. So we have GBM, gradient boosting machine regression, written in R, and we're also releasing one written in Python, XGBoost.
All right. Thanks, Sweta.
Yeah.
Okay, well, are there any other more questions from the audience? Thank you, Sweta, for the wonderful, again, for the wonderful talk and presentation about this. And remember that there is a new TIBCO Data Science channel on YouTube. And the new format, well, it's been like, this is like the third or fourth new delivery format. Is not longer in Zoom, now it's in live, Facebook, YouTube, LinkedIn. So uh, please subscribe. And if there are any last comments from you, Sweta, we can call it a day.
No, that's about it. So thank you for joining this, continuation of our intro to ML. I think it's a very popular topic, and hopefully it gives you a quick overview of some of the Kotlin algorithms that are being talked about.
Remember, the first Tuesday of every month we have talks about this, and you can check the content on the on the on the Dr. Spotfire webpage. We're gonna post and answer questions after this session is over. And thank you. Please keep safe now, and happy New Year again to everyone.
Thanks, everyone.
Bye bye.